Hello, everyone. Really excited to be here. How are you? More energy. We're just beginning. Okay, so I'm here today to talk to you about things you probably didn't know you can do with React Native. A little bit about myself. I am Vladimir Novick. I am a software architect and I work at Code Value company, amazing company. You're welcome to talk with our representative there in the break. And there's my website, so if you can, if you want to contact me or just say hi, you're welcome. Today we will talk about three things. One thing, we will talk about non-standard animations. How much of you aware or using React Native on a daily basis? Great. So you know animated library probably or layout animation. We will go a little bit beyond that. We will talk about physical things that surround us, how we can connect to them from React Native. And for the end, for dessert, we will see a little use case of something of native model bridged to extreme, I would say. So, about animations. Why animations are so important? There is a saying, magic is both in the details and in the performance. It's a saying of one magician, Darren Fitzky. What does it mean? It means that in interaction design, it's not the color and the shape and the lines, not only them important, but micro animations, micro interactions are also very important for user. And that's basically what makes your app outstanding. Our regular solutions, as I mentioned before, are animated layout animation and React Native animatable. Of course, there are also other libraries you can use, but that's basically the main usage. But there are more. What if we want to create animations that are beyond simple interpolation between values? If they actually modifying the shapes, something like this. How to create this? Right? We cannot create this with animated, we cannot create this with layout animation, nor with React Native animatable. So what basically we have for that? For that we have this amazing library, React Native Lottie. Lottie is a native library that takes JSON exported from After Effects by your designer. Animation is created by your designer. And it's exported using body moving plugin. And basically, you can use this JSON to embed it inside your application and run it in the native world, right? It's not running in JavaScript, it's running in native world because Lottie is a native library. So React Native Lottie is a wrapper around it. Something like this, for example, right? So it's basically two animations, one on another. Maybe background we can create with animated, taking linear gradient and turning it around, right? But we never can create something like React logo. So how we do this? We take animation, of course we install Lottie React Native, and we import animation from it. We set our animated values to state. In this use case we have progress and background progress. And then we run a regular animated timing function with usage of native driver, of course. And we simply put our animation component with the JSON. And it simply works, right? So it's an amazing library. Also, it gives you ability to, instead of declarative way, to call animations imperatively. But usually, if you're in React world, you want to make things as more declarative as possible. So what if we want to work with image content? We want to animate or change actual representation of our images. what our use case there? We cannot use Lottie there because it's basically not vectoral graphics, right? So, and we want, for example, custom transitions. Something like this. This is a long video, so I will probably rewind a bit. We can change sepia colors of the image. We can basically create our, put text on the image, right? To change colors. We can create progress bars. We can blur images. And we can do much more complex things. Like this one, which is, yeah, something like this. This is not possible, right? Nor with animations, nor with animated, nor with anything else, except this library, GL React Native V2. V3 will be soon. Basically, there's a library called JL React. This library is implementation of OpenGL, JLSL language. So you can write actual shaders for your image. It runs natively on native thread and does run in JavaScript. JL React Native passes all the shaders to the native thread, and you have these amazing images. But the syntax is not really nice, right? Basically, what you see here is in the last example of shaders, we've seen like a blurry bar, right? Blurry banner. I will remind you. Something like this here, right? So if you look closely at it, you can see that it's transformed in a wavy matter, right? That's what we can see here with using sinus and cosinus computation. Basically, we create these wavy reflections. But of course, it's much more to the hardware, like they say, instead of using animated libraries. But sometimes you want to do these effects. For example, if you want to create like Instagram filters or stuff like that. Okay? So this is animations. But there are also another amazing thing I wanted to talk with you about physical things. We are surrounded in the physical world by regular things, right? So you may ask, what do I mean by saying physical things? Like I won't talk about chairs, right? Well, stuff like that. Basically, I will be talking about merging between digital and physical worlds. Like we know what are smart homes, right? We know what are devices that by their geolocation give you some interactions, right? For example, let's take Uber. By knowing where you are, you can see drivers around, right? So basically, by letting our device to be aware of physical context, we change the way we interact with the user. And ultimately, the way we develop our apps. But we know about geolocation. I just told you about Uber, but geolocation is not really enough. For example, if we want different interaction from right side of the stage and from the left side of the stage, geolocation will give me approximately the same spot, right? It's up to 50 meters, something like that. Sometimes more precise, but still, it's not enough. So we need something more precise to give us the exact context. So for that, we have beacons. Beacons is an amazing technology that was introduced a couple of years ago. They are in several formats. One format I will talk with you about and show you example is iBeacon. It's format introduced by Apple 2 or 3 years ago, don't remember correctly. And basically beacon is tiny Bluetooth low energy transmitter that transmits unique ID and basically proximity. Basically it transmits, here I am, this is my ID. That's what it says. And it does it using JP protocol. JP protocol is a protocol part of Bluetooth, which means, in a nutshell, when you're looking at your Bluetooth devices that are around you, right, you see them, you see this is the device, right? So have you thought one day, how do you actually see these devices? Basically, it's done by JP protocol of the device, of the peripheral, which transmits a packet of a really small amount of data, of 31 bytes of data, and it basically lets the device to connect and to request the data, how to pair with the device. So beacons use this protocol for just transmitting the unique ID, and we use it for proximity. So you may say, okay, so I have small beacon that just yells out there, here I am, here I am. But what we can do with these beacons? We can do lots of things. We can do indoor navigation, precise indoor navigation. We can do proximity marketing, automatic check-ins, contactless payments, lots of stuff. For example, this example is from one of the stores that has beacons. You enter the store with an application, store application. And when you come to let's say you choose jeans, and you come to the jeans shelf, you get, on your phone, you get a message or notification, this jeans is for sale. And of course, it can go much more beyond the simple advertisements. Museums, really nice use case. You go into a museum, basically you search for, in Google, you search for artwork. You search what this artwork, or you just read the caption on the artwork. But if on this artwork there is a beacon, and you have a museum application, you get a notification, or if your application open, you get basically the description of the artwork, including videos, including much more engaging content, right? It can be also used for education, of course. It can be used for navigation, indoor navigation. For example, lots of airports in Europe and US already using beacons. And they have, this is example of one of airport that is using indoor navigation. Basically, in a nutshell, how it's done, you take a map of an airport and you deploy beacons all over the place, right? So basically, if you want to move from point A to point B, you just need to execute well-known pathfinding algorithm from point A to point B. And these nodes on the way are basically your beacons. So, of course, everything, this can be done. Let's look at this picture. In this picture, we see that basically the example of museum. This square represents what we already do in the museum. We already search for the artwork, right? Beacon gives an ability to predict user intent. Of course, it's sometimes not really correctly. We cannot read user's mind yet. But we can predict, approximate what user wants to do. So how we develop our apps in React Native and in general for physical context-aware apps. We enable location services in our app. That's pretty obvious. We need to get also geolocation and, of course, location services unless beacons won't work. Then we start scanning for beacons. If there are beacons around, then we check the closest beacons against server. What does it mean? It means that beacon only has proximity, right, and unique ID, and that's it. But we want additional data, right? So on the server, for each beacon, we can have lots of data which are relevant to the app you develop. And then when you are near the beacon, then you execute this custom logic based on the closest beacon. It's demo time. Let me show you how it looks like. I prayed to demo gods, so I hope everything will work. Yeah. This is my phone, and this is 2 beacons I have here. This, let me show you. Everyone sees, have like small devices here, right? One is called Pack.js, is a handmade beacon, basically programmed with JavaScript to transmit like iBeacon. And this is XY tracker. This is regular device you can buy and track your wallet or keys or stuff like that. And I want to show you how precise the proximity is. I have Pack.js here, right? And I have, okay, it will be hard. Okay, so I have here the XY tracker, and I have here Pack.js, right? And you see the first one is XY tracker, and the second one is Pack.js. Now I switch them. It will take a little bit time, and they're switched, right? It's 40 centimeters, right? Can geolocation get that precise? I don't think so. So you see with this, so basically you're seeing that it's really precise. We can really really develop very precise physical context-aware apps. And I have, if you want to watch slides later, I have the same demo here in the video. So for React Native, how we do that? We have libraries called React Native Beacon Manager, and we start like that. We, first of all, import this library. Of course, we install it, and we link it. Then, let's say I have a server. I don't have, it's a demo app. I don't have a connection to server here, but I have like a regions array, which are my regions that I differentiated by unique ID. Beacon has 3 unique IDs. It has 16-byte unique ID called here UUID, and it has minor and major. Basically, UUID is my region. So for example, this building will have beacons with the same unique ID. But their minor and major will be different. So it will be enough to differentiate between these beacons. So here you see in the regions, I have like identifier. Yeah, I had to change that here. And I had latitude and longitude. And I have a beacons registry. Beacons registry are basically UID, major, minor, name, image URL, and stuff like that. I have a typo here. So basically what it means, as I said, beacons have only UID, minor, and major, right? This is like my server-ish thing, which gives additional data to my beacons. And I have geo accuracy. This is accuracy for like 200 on 200 meters in terms of geolocation decimals, geolocation decimals. Then I set my state with region and beacons, which are basically nothing at the beginning. And when my component will mount, I start requesting for authorization. I need to request authorization from user because it's if I don't request, I violate permissions, and it's not really good, right? So I get current position with my regular navigator I use in React Native, and I filter my regions by latitude and longitude, and I start looking for beacons with specific UID. This means I start looking in this area for specific UID, and from now on, I compare minor and major. I already know that I'm looking for this unique ID. I have event emitter here, adding listener on beacons did range event, and if I receive beacons, I basically set state to beacons, and my array gets updated. And then I basically map on all my beacons array and merge it with registry data, the same data we looked at the beginning, and render all. That's what you've seen in the application right now. And this is the merge with registry data function. So I compare unique ID, major and minor, as I told you before. So that's basically how it's done. Of course, it can be with much more content. And basically, if you need indoor navigation, you also will store much more like directions, where to turn, stuff like that. But here is a simple example. So we've talked about beacons, but now we will talk about smart homes. It cut out. It's a pity. Basically, what it says here, we have to go for dinner. The refrigerator isn't speaking to the stove. Yeah, that's the common use case in the smart home, but we have to deal with it. Let's just go straight into the demo, right? Work again. Okay, so, ta-da! I have here light bulb, which is changing when I change colors, I change opacity, and basically it's a light bulb controller app. I have this light bulb in my home. I decided to make another controller for it in React Native. Okay, so, wait, let me turn it off. So that's the use case for a basic smart home. Let's see how it's done. It's done with a library called React Native BLE PLX. There are lots of libraries that are using Bluetooth Low Energy, but this one is more reactive one, and it uses under the hood RX Java and RX Swift, which are basically like a new emerging standard for the in the native world. How we connect basically to this light bulb. First of all, before looking in the code, I have to say something. In Bluetooth world, there is, when you connect to something, to some peripheral, it has services and characteristics. Services are basically characteristics grouped by logic. The characteristics, you can treat them as variables. So basically, if I have this watch, for example, and on this watch, I have like a heart rate, right? This heart rate will be a service, and the actual data on the heart of my heart will be characteristics. Characteristics can be written, read, or observed. So how we basically create this? We take buffer and we take BLE manager from React Native BLE PLX. I have this specific ID, unique ID for the light bulb. I create my manager. I have some things in the state. And basically, I subscribe to state change. When my state changed from power on to power off, and I'm not talking about the bulb, I'm talking about power on and power off of Bluetooth in my device. So if I just open settings and click Bluetooth off, this will be triggered. Then this function is triggered. And when I click on the screen with my light bulb, or LED toggle, or I call scan and connect. The most important LED and toggle is just setting toggled off. It's not really important, and scan and connect is the one that initiates the device scan. I start scanning for device around me. I don't know if LED is here, so I cannot say connect to this device with this ID, right? I need to start scanning first. So that's what I do. Then if my device ID equals to ID of LED bulb, then I stop scanning for devices and I connect to LED. Connected to LED is as simple as running device.connect and my LED is paired and connected. Then, in order to connect to the actual service and characteristics that enables light on this light bulb, I call discover all services and characteristics. I need to discover them first, right, before connecting. Then I create new base64 value. It's some weird numbers here, 56 or F, this kind of stuff. Basically, if you have like a not cheap light bulb as I have here, it's usually written in documentation. If it's not, you can, I can call it reverse engineering. It's not really like that. You can sniff for the network, looking what packets are sent from the official app of this light bulb to the light bulb itself. It can be done or on Android by logging logs and filtering them later through Wireshark, or it can be done by using a dedicated piece of hardware, Bluetooth sniffer, with specific software, of course. Then after I created my value, I write characteristics with response. I want to know if I get error or if everything was okay, right? So I write for this specific service, this specific characteristics, value. You may ask, okay, looks okay, but how do you know these services and characteristics values, this unique ID, right? It's not something that I retrieved from doing reverse engineering or from doing packet sniffing. It's something that I can log when I develop my app. And it can be done in this way. I call again, discover all services and characteristics to discover them. And then I call services function on the returned response, which result in a services array. Services array are passed with a map into, I basically map on services array and I call asynchronous function on called characteristics on server. And in the result, I do promise all and get characteristics array. Of course, it can be done by chaining promises. It can be done by using react.js. And finally, I log my service array and log my characteristics array, so I have the data. I know that in this specific light bulb, only one characteristics can be written, and basically it works, right? So the final thing for today, bridging taken to extreme, right? So up till now we've seen lots of libraries, and all these libraries have one common denominator. All these libraries have native code behind them, right? So in React Native, API of bridging between native code and JavaScript code is really straightforward. It's really easy and described well in the docs. And basically with ability to bridge between native models and JavaScript, you can do anything you want. So I wanted to create some extreme example of something that haven't been done till now, I guess. So I've taken a Unity 3D game, and I put it inside React Native app. And it's running on Android. And it's looking like this. And it's running. And I have regular Unity 3D game running inside React Native application. And most important, if I want to exit it, I want to get back, right? So I'm getting back to React Native. And this is done by basically bridging between native code and JavaScript. So I want to summarize this talk with one thing. All these libraries were created by people like you, right? All these libraries give us ability to write really awesome code. I want you to not be scared to bridge native models, because that's the main recipe to create cool stuff. And I bet you all want to create cool stuff. And one final thing, you were awesome. I wrote and published 2 weeks ago a book about React Native, and you all get 50% discount on it. So if you want, this is the code. You can go to vladjs.com and click there on link. And if you tweet this thing, one of you at the end of the day will get a printed book. So enjoy, and thanks.